All right, so what we're noticing is that, just to recap for the folks at home who I didn't record this for, we noticed that this is very similar to what we've been doing, swapping between component forms. We're given two variables in terms of a third variable. The third variable is called the parameter. That would be, in this case, t, because we've got an x value. Since it's horizontal, that would be our x value. Since this is vertical, this is our y value. We show that here. The parameter interval is going to be from 0 to 4 seconds. That's because we know that the parameter at the time is from 0 to 4. Okay? After t seconds, we know that because that showed it here. So there's my interval. And if we actually graph these things, we get a parametric curve, which is really taking those two variables and turning them back into sort of one, isn't it? One graph that actually should be a parabola, because we know the graph, we know the height of something, how it falls, is if we throw something, it's a parabolic curve, isn't it? So we plug into the f of t to get this. We plug into for here and here, and we get this. So let's practice again. Now, something really cool. I'm going to let you do one more by hand, and then I'm going to show you something really neat. Okay? So it says, gets the curve given for each set of parametric equations over the given interval. Use arrows to indicate the direction of the curve as it increases. So what is my parameter value? This is my interval. This is my interval, right? This is my parametric interval. Now, what is my parameter, though? That means, what variable are we using to describe the other two variables? T. So t is my parameter. So if we want to graph this, we need to set up a chart, don't we? So t goes in the first. What goes in the second column? X, because that's what's here. And what goes in the third column? Y goes here. All right, so where does my t value start, and what do they go through? Yep, -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, now I'm going to show you something really interesting on your calculator. I want you to go up to mode, and I want you to go down. Right now you've got it in function mode. What is written right next to function mode? Parametric is, isn't it? Click over onto parametric and hit enter, and then quit out. Okay? Now I want you to go, did everybody get it switched to parametric mode? Okay, give you a second. Go to mode. Go down to where it says function. Right next to function is parametric. Highlight that and hit enter. Then quit out. Now, does everybody have it in parametric mode? I want you to hit your y equals this time. What do you notice now? It says x of t, y of sub 1 of t. It's going to allow you to put both of those equations in at the same time in terms of t. So if you put the first one in as what? T squared minus 7, hit your x button. It's t now. So t squared minus 7, and then arrow down and put the other one in. That would be what? T over 2? And then plus 5? I would probably put the t divided by 2 in parentheses. All right, so does everybody have your equation in? Yes? Okay, so quit out of that. Hit second window for your table set. Where do we want our table to start this time? -4. We want it to go up by 1, don't we? Do you have that in? Table start at -4. Now hit second table, second graph, and look what it's going to give you. It's going to give you the solutions to both of those, isn't it? Giving you what? Meanwhile, you can use that table to copy those values into your table. Okay. It's because you're still in X mode. Did you change to parametric mode? You did. Why are you still in X? I think you put them in before you swapped. Here you go. Now it should work. Second table set. Starts -4, second table. Yeah. All right. So now you can copy all those values down nicely. Never say I didn't do anything for you. You don't even have to actually do any math, do you? That's okay, though. So we know these values are 9, 3, 2, 3.5, -3, 4, -6, 4.5, -7, 5, -8, 5.5. I can just really kind of see what's going on here anyway. Oh no. Yep. And now look what happens. It swapped again, didn't it? Hold on. What just happened here? Was I not paying attention? -4, 9, 3, 2, 3.5, -3, 4, -6, 4.5, -7, 5, -6, 5.5, -3, 6. Oops. At 1. Oops, that's where I went wrong. So -6, 5.5, -3, 6, 2, 6.5, and 9, 7. Okay? Yes? All right. So now we have to graph all of these. Now, if you want to graph, it'll graph both of the parametric equations for you. It'll graph the x and the y for you. Don't hit it, though, until you adjust your window. What is my hit window? Your minimum t-value is what for this? No. Your minimum should be -4, so I'm going to go to -5. What is my maximum t-value? 4, so I'm going to go to 5 this time. And I'm going to go by ones, aren't I? I already see what my minimum x value is, my maximum x value. I just need to make sure they're all in there. Scale by 1, min, max, scale by 1. Now I can hit graph.
Is t-step supposed to be 1?
Yeah, should be. X min -10. X max +10. Scale of 1. Y min 0, because it's not going to be negative. Y max is 10. You better change your 10 scale 1. I'm buzzing. I was buzzing. I was like, what's going on?
The second time I called you, I was like,
I know. Ignored it the first time. Thought it might be my son. All right. Trying to figure out why I'm getting an invalid dimension. Is anybody getting an error when you try to graph?
Should is.
Yeah, I'm trying to figure out why I'm getting an error to graph too. Catherine. No. Minimum t is -4. Maximum t is 4. T step is 1. Why? Oh, I know. Stat plot. I got a stat plot on. I should have checked that first. Yep. Okay. Make sure your stat plots are off. Now hit graph. You should get a sideways parabola. Did everybody get a sideways parabola? Okay. So you can see it's going to graph your graph for you. And that's what should end up here. Yes. You can see what's going to be here. That's what your graph should look like, isn't it? So it's going to graph it for you too. Now, you still need to put it on this graph by hand, but you got a way to double check your work, don't you? Did everybody successfully get it to graph? Anybody having any issues? Yes, it is. It is supposed to look like that. Okay. So if we graph this, we're going to graph these pieces, aren't we? This is my x and y coordinates. So over 9 up 3. Over 2 up 3.5. -3 up 4. -6. 4.5. -7.5. -6. +5.5. Oops, here. -3. +6. So you can see where this is going. It's starting here. It's traveling this direction. Now, thing is with the parametric, because it's in terms of time, we need to draw which way it's going. So we need to show that time is traveling this way. Do you understand? So as you graph it, start it and show your arrows the direction it's going. Then we have 2, 6.5. And then finally 9, 7. Showing that it went that way. So does everybody understand? We are actually tracing the path. If this were a bug and that was describing its motion, we are tracing the path of the motion of the bug, aren't we? I would like for you to try one more. Try number 4 on your own. Set up your chart for X and Y. I do want to see those values even if you're putting them on your calculator. You know where it should start, you know where it should end. Then go ahead and put them on your calculator to generate your values and graph them. And then double check your graph on your calculator, right? So this is my interval. This is my parameter. Okay, so now, how do I do this? I have changed my calculator to parametric mode. Make sure you do that. Hit mode, go down to function, go over to parametric, hit highlight, quit out of that. Make sure your stat plots are off, y equals. Clear both of those out, and then put these in. So we have t squared for the first one, 3t minus 2 for the second one. Quit out of that. We're going to hit table set. We're going to start this time at -2 and look at our table of values. That gives us +1. And I'm literally just taking these right off my calculator table. Okay. I am now going to go into my window, make sure my window is okay for all of those values. It should still be okay. And hit graph and see what the graph looks like. Okay, so it's kind of a curve, right? So now we're going to graph our points and see if it fits. Four, -8. One, -5. So now we're going this way, putting my arrows in as I go. 0, -2. 1, 1. Continue to put arrows as I go. 4, 4. 9, 7. And I'm going to keep going with 16, 10. We got to just keep going, don't we? 16, 10 would be right here, approximately. 11, 12, 13, 14, 15, 16. Yep, right here. And we stop it. We don't put an arrow on the end of it. We keep it. It goes a certain pathway, doesn't it? So it starts here and ends here. If I were a bug, this is what I would have crawled using those parameters, okay? So are we good with how we graph these and how we find the values? It's pretty much calculator work at this point. We like that, don't we? All right, so now let's actually tie this into what we learned before, which is writing parametric equations in rectangular form. How do we do this? Look at what it says. It says solve one parametric equation for t. And then we're going to sub into the other one for t. If we do that, then we'll have it in terms of x and y, which should give us the exact same equation that we had if we graphed it the other way. It's substitution, guys. It really is substitution. All right, so let's do one of these. We have x equals 4t minus 1 and y equals 6 minus t. It does not matter which one you use. So let's take x first. So we're going to take x equals 4t minus 1 here, and we are going to solve for t. So how do I do that? Move -1 over, so we have x plus 1 equals 4t, and then what? Divide by 4. And now I have t equals, so I have t equals x plus 1 divided by 4. So that's this piece. Now I have to take and put it where? Yep, I'm going to take all of this and plug it in right there. Get it? So let's actually do that now. So now we have y equals 6 minus x plus 1 over 4. If you'd like, and you don't like it this way, and you don't like working with fractions, go ahead and multiply through by the denominator, which makes this 4y equals 24 minus x plus 1 here, doesn't it? Get it? Multiplied by 4, multiplied by 4, multiplied by 4, so this went away. It will divide back out again. I know most of you don't like working with fractions, so what's the problem? 4y equals 24 minus x minus 1, so we clean this up. 24 minus 1 is x, and now we do what? Divide through by, divide each thing through by 4. So what should this thing look like? If we literally have y equals -1/4 x plus 23 over 4. You know why I wrote it that way? Because it's easier to tell what the equation is of. What is this the equation of? This is a line, isn't it? Y equals mx plus b. So this is my slope, right? This is m, this is b. So we know this is a line. It's a diagonal line, isn't it? So do me a favor, please, and put those two. You're still in parametric mode, aren't you? So go up to your y equals, clear those out, and put those two equations in and graph and see what you get. Hit graph and look what I get. You do it. Is it a diagonal line? Yeah, it is. So you try one. Actually, let's try one more together. Let's do two together, and then I'm going to make you do a couple. And then we'll move on to the last little chunk of this lesson. So which one do you want to use? So you got choices here. Which one do you want to do? Yes, smart choice, Ethan. We should use y to get it in terms of t. Why is that? It has the same number of variables. It doesn't have this. Because how are we gonna undo the square? Square root, and then we have plus or minus, and that'd be ugly, wouldn't it? So given the choice of one that's squared and one that's not squared, we need to choose the one that's not squared to do first. Okay? Make wise choices. So y equals 3t. How do I get this in terms of just t? Divide by 3. So I get t equals y over 3, don't I? Now I need to take that and I need to plug it in. I need to take all of this and plug it in right there, don't I? So I'm going to rewrite this. Y over 3 squared plus 5. Now I just need to work this out, don't I? So x equals what? Y squared over what? All right, guys. Now look. If we're solving this in rectangular form, it needs to be, when it says in rectangular form, it needs to be y equals something, doesn't it? So anytime it says rectangular form, we're going to have y equals some function of x, right? So how do I get this how do I get this y apart? Yeah, you can move the 5 first. It's fine with me. So this becomes what? X minus 5 equals... Okay, now what? Multiply by 9. Good. So now we have y squared equals 9 times x minus 5. Okay. Now what? Square root. And what are you going to forget to do? What's going to be the problem here? You took the square root. You got to do plus or minus, don't you? So plus or minus 3 times the square root of x minus 5. I didn't leave the 9 underneath the root because you can actually take the square root of 9. Now, it says note any restrictions in the domain. Are there any restrictions in the domain? This goes right back to the very beginning of this class. How do I know I have restrictions in the domain? This is up underneath there, underneath the square root, isn't it? Bringing stuff back, isn't it? So we need to restrict this to be what? X minus 5 must be what? Greater than or equal to 0. Right? We can take the square root of 0. We just can't take the square root of a... Now, the reason we can't do that is because we're trying to make a real graph. These are real functions. That would be an imaginary function, which wouldn't work. So x has to be what? Yeah. Greater than or equal to 5. All right, but that's the domain restriction for x. What we're really looking for is the domain restrictions for t. So what we do is we look up here and we see, does that affect it? Does x being greater than or equal to 5, I want you to look at this and compare it to this. Is there any value of x at all that is there any value of t at all, looking at that t squared, is there any value of t that is ever going to make x less than or equal to 5? Nope, there isn't, is there? Because this is 5 right here. And every value of t that you square is going to become positive. No matter how small it is, it's still going to add to 5, isn't it? So overall, do we have any domain restrictions on t? So no on t. Okay? So here we go. I want you to try number 3 and see if you can't get it in terms of y in terms of x. And then look and see if there are any domain restrictions. All right. Did you get it?
I'm at the 205.
The 2 was up top. It's 2 times t squared. I did. But then I squared this. So 1 minus x squared is this. 4 squared is 16. 2 goes into 16 8 times.
Oh, okay. Yeah,
Ta-da.
sorry. I was very confused. I was like, I get it.
Mm-hmm. That's how. And then I multiplied through by 8. And then notice I had to expand that out. I had to expand out the 1 minus x squared, right? Square, double, square. Your shortcuts here, your algebra is going to be important. You should be able to do this. Okay? All right, let's look at one more where we actually have a restriction. And you'll see why we have a restriction. Anybody have any other questions on 3? Are we good? Yes, no? I did square it. 1 minus x squared is 1 minus x times 1 minus x. 1 minus x is minus 2x plus x squared.
I get it now.
Okay.
I looked at it weird and then I realized that.
Yeah. The temptation is going to be to do 1 plus x squared, but you can't do. There is a middle term. There's always a middle term. That's why I say square, double, square. Okay, so let's look at 5. I know there's going to be a restriction on x because there is a restriction on t, isn't there? If there is a restriction on t, there will be a restriction on x. So this will restrict x, okay? So let's figure out what that restriction is going to be at the end here, and let's actually do the swapping. Can y'all swap? Go ahead and practice writing y in terms of x. Do what we just did above. It's good practice for you. Guys, you should be doing this on your own and check your work. That's the only reason I show this. Try it on your own. Don't just copy down what I wrote. Otherwise, how are you ever going to do it on your own? Okay, so did everybody at least get to y equals 4x squared plus 24x plus 29? Yes, no? Any questions about how I got there? I squared the outside number, then I squared x plus 3, and then I distributed it in, and then I simplified, okay? Now, let's talk about it. There are no restrictions on x from this equation, are there? That will accept any form of x, won't it? So the only restrictions are going to be from t. So do you know how we figure out what x is? The restrictions on x are? We take this value of t and we plug it in. What are we going to get? -2. Then we take this value, which is the upper value of t, and we plug it in. So 1. So our restrictions are x lies somewhere between -2 and 1. Make sense? Now, if there are restrictions also from the equation, then you have to be very, very careful. Let's look at one more of these together, and then we've got to move on to the last little chunk, polar to parametric, which is going to be really easy. Okay? Is everybody good with this?
I thought you said before that if there was no T restriction, there was no X.
But there is T restriction.
So if there's T and X, then you have to place all of them?
Yeah. Typically, if there's T, then that will carry over, because this is what I want you to look at. I want you to look at number 7, right here. If we look at number 7, there is no restriction mentioned on T, but there is a restriction on T. Can anybody tell me what the restriction on T is? T cannot, look right here. So we know T cannot be 0. If T cannot be 0, then what? Can we plug that in? We can't, can we? So we can't plug this in until the very end, because we got to figure out, because if you plug in 0 right here, it's just going to make that undefined, isn't it? And we can't factor it out. So we're going to have to look at what do we get. Now we could rewrite this if we wanted to see what it would be. T divided by T is what? 1 plus 2 over T. I want you to think about this. What's the limit of this thing as T approaches 0? What happens to this chunk as T approaches 0? It goes away, doesn't it? So there's an easier way to see it, though, because that's just going to make it hard on some of you. So let's go ahead and solve. Very quickly, let's solve this. Which one you want to solve? Okay. So let's do y equals 1 over t. So t equals 1 over y. Yes? Okay. So let's plug this in. Now what?
Get rid of it.
How do you get rid of it? One over y plus 2 times y over 1, right? Compound fraction. Flip it and multiply. So this times this. So we get x equals what? 1 over, we just get 1 here, don't we? So this is 1 plus 2y. So now what? Now we just solve, don't we? The algebra is what's kicking your butt still. Guys, if you have a compound fraction, dividing by a fraction is the same as multiplying by its reciprocal. So we flip the 1 over y over and we multiply it through. So we get 2y equals what? X minus 1, which means y equals what? That still doesn't help me with what x can't be. So what x can't be, we've got to go back to this. And you know what we're going to do over here? This is my equation. But I'm going to go over here and I'm going to figure out, I'm going to rewrite this in terms of t. How do I rewrite this in terms of t? Guys, I can cross multiply here, can't I? Yes? xt equals t plus 2. Well, I got to get the t's on the same side. Do you see why I just did what I did? I subtracted t over, because now what can I do to get t isolated? Both of those terms have a t in them. So what do? Factor it out. So now t equals 2 over x minus 1. Now we can figure out what t can't be. Because t can't be what? 0. So what happens if we plug a 0 in right there? Guess what we can find? What will make t go to 0? 2 over x minus 1. What is going to make this guy be undefined? Really, it's not 0. It should be, let's think of it this way. What will make this be undefined? Ah, that's what's going to make this whole thing undefined, isn't it? Does that make sense to everybody? We don't want, if t is 0, x goes undefined. So we want to know what makes t go undefined. So if x equals 1, t is undefined. So guess what? X cannot be 1. It's weird. All right? Now we need to finish this up. Polar and parametric equations. Guess what x is equal to? Does this look familiar? Guess what f of theta is? The radius, which is the magnitude, isn't it? So it is the magnitude times cosine. So guess what y is? Same thing. F of theta times sine theta. And guess what they've just given me? So what is x defined as? 3 cosine theta. And y is 3 sine theta. Yes? All right, so let's do one more. And then we'll go the other direction. X is r, because remember this is r, 4 sine theta times cosine of theta, isn't it? And then y is going to be 4 sine theta, which is 4 sine squared theta. Yes. All right, so now what happens if we want to get it back the other direction in terms of x and y? We have to solve for what? Well, how though? Because it's not the same here, is it? So what do we need to do? We got to get rid of theta. So we got to solve for theta, sine theta and cosine theta. Watch. This becomes x over 3 equals cosine theta, doesn't it? This becomes y over 2 equals sine theta. Well, here's a question for you. How can can I get cosine and sine to be in terms of x and y? I want you to remember a property we know. What do we know about this? Oh! If we plug those two things in, aren't we getting rid of the theta and aren't we putting the x and y in? Huh, how about that? Pythagorean theorem, right? For sine and cosine, that trig theorem. So sine squared plus cosine squared, sine squared becomes what? Y over 2 squared. Cosine becomes x over 3 squared. It all equals 1. So now this becomes x squared over 9 plus, look what it said, use trig identities to eliminate the parameter. Holy smokes. That same thing will work for every one of these with one exception. This guy right here, because look what we have there, cosine of 2 theta. But you know, go back and look, cosine of 2 theta is equal to what? 2 cosine squared theta minus 1. That's my trig identity, isn't it? So solve for and plug in. And you'll get it in terms of x and y. Okay? So this becomes x. This becomes y squared. Ta-da! Easy peasy. Do you see why I say it relates to what we've been doing with the vector component form? All right. So next time on Friday, you have what? Test on your unit. Make sure that you finish your review and check it online. Y'all have a good rest of the week, and I will see you on Tuesday. Okay? All right.